every night, without fail, we cross a strange border. Our bodies lie still, our eyes close, and yet our minds begin to move in unexpected ways. We fall, we fly, we run, we panic, we laugh. We visit places that do not exist and relive moments that never happened. Then we wake up, and most of it is gone. Dreaming is one of the most familiar human experiences, and at the same time, one of the least understood. For centuries, people tried to explain dreams through myths, symbols, or divine messages. But from a scientific point of view, dreams posed a serious problem. You cannot hold a dream in your hands. You cannot measure it directly. You cannot see someone else's dream. And if you ask people what they dreamed about, the answers are often vague, inconsistent, or unreliable. In fact, research suggests that we forget around 95% of our dreams, often within the first 10 minutes after waking up. By the time you sit up in bed, the story has already started to dissolve. A few minutes later, only a faint emotional trace remains. This extreme forgetfulness made dreams incredibly difficult to study, and for a long time, the scientific study of dreams, known as oneirology, barely existed at all. That began to change in the middle of the 20th century. And before we go any further, if you enjoy exploring the hidden workings of the mind, take a moment to like the video and subscribe. It really helps the channel grow. In 1952, researchers at the University of Chicago noticed something unusual. While monitoring sleeping subjects, they observed a distinct pattern of electrical activity in the brain that appeared only during a specific phase of sleep. During this phase, people's eyes moved rapidly beneath their closed eyelids, darting back and forth as if watching something unfold. This stage became known as REM sleep, short for rapid eye movement sleep. When researchers woke people during REM sleep, the results were striking. Almost every time, the subjects reported that they had been dreaming. Wake them during other stages of sleep, and dreams were far less frequent or far less vivid. For the first time, scientists had found a reliable biological marker for dreaming. REM sleep opened a door. Dreams were no longer completely invisible. They left traces, electrical signals, eye movements, and chemical changes in the brain that could finally be observed and measured. One of the most surprising discoveries about REM sleep is what the brain looks like during this phase. If you examine the brain's electrical activity, it closely resembles the pattern seen when a person is awake. In many ways, the brain is just as active, sometimes even more active during REM sleep as it is during the day. But there is one crucial difference. During REM sleep, the brain dramatically reduces the production of certain chemicals, including norepinephrine, serotonin, and histamine. These chemicals are closely linked to alertness and physical movement. When their levels drop, something remarkable happens. The body's muscles become effectively paralyzed. This phenomenon is called REM atonia. Thanks to REM atonia, your body does not act out your dreams. You can dream about running, flying, fighting, or falling, and yet your physical body remains still in bed. Without this protective mechanism, dreaming would be far more dangerous. For most people, REM atonia works perfectly, but in some cases it fails. Individuals with certain REM sleep disorders do not experience full muscle paralysis. As a result, they may move during their dreams. Some talk, some kick, some punch, and some even get out of bed and walk around, acting out their dream scenarios. In extreme cases, this can lead to injuries for both the dreamer and anyone nearby. This breakdown reveals just how real dreams are to the brain. During REM sleep, the mind is not passively imagining, it is fully immersed in a constructed reality. And sometimes the boundaries blur in the opposite direction. Most people will experience this at least once in their lives. You wake up, you are conscious, you know where you are, but when you try to move, nothing happens. Your body feels heavy, unresponsive, locked in place. Panic rises. A few seconds or minutes later, control returns. This is sleep paralysis. Sleep paralysis occurs when the mind wakes up before REM atonia has fully shut off. The brain is alert, but the body is still in dream mode. The experience can be terrifying, especially with fragments of dreams spill into waking consciousness, creating vivid hallucinations or a sense of presence in the room. It's the mirror image of another strange phenomenon, knowing you are dreaming while still asleep. Imagine realizing in the middle of a dream that none of it is real. This is known as lucid dreaming. In a lucid dream, the dreamer becomes aware that they are dreaming and, in some cases, gains the ability to influence what happens next. You might choose to fly, explore impossible landscapes, or simply observe the dream without fear. Lucid dreaming is especially appealing because it combines imagination with conscious control. However, it is also notoriously difficult to achieve. While some people experience lucid dreams naturally, others require extensive practice, techniques, or training, and even then, success is not guaranteed. Lucid dreaming highlights an important fact. During sleep, consciousness does not simply switch off, it changes form. Dreams are fascinating, but they are not the main reason REM sleep is important. Experiments with animals have shown that depriving subjects of REM sleep leads to serious consequences. In classic studies, researchers prevented mice from entering REM sleep by placing them on small platforms surrounded by water. The mice could sleep, but the moment they entered REM sleep and their muscles relaxed, they fell into the water and woke up. The result was clear. Mice deprived of REM sleep had severe difficulty remembering things. The same pattern appears in humans. When people learn new information, such as word pairs, and then are prevented from sleeping, their ability to recall that information the next day drops dramatically. Memory formation suffers. But memory is only part of the story. When someone learns a complex new task during the day, playing a musical instrument, solving a difficult puzzle, or mastering a new skill, scientists can measure the specific patterns of electrical activity in the brain during that task. Later, during sleep, something remarkable happens. The brain replays those same electrical patterns. Even though the person is unaware of it, their brain is rehearsing, strengthening connections, and refining neural pathways. REM sleep appears to play a key role in this process, helping transform short-term experiences into long-term memories. This has led many researchers to propose that dreaming is connected to the brain's effort to organize, consolidate, and optimize information. One of the most popular theories about dreaming builds on this idea. According to this view, while we sleep, the unconscious parts of the brain are busy sorting through memories, strengthening useful connections, and discarding irrelevant information. This process generates a flood of electrical signals. The conscious brain, the cortex, detects this activity and tries to make sense of it. Faced with disconnected signals and fragments of memory, it does what it always does. It creates a story. The result is a dream. From this perspective, dreams are not meaningful messages or hidden symbols. They are epiphenomena, byproducts of a much more important process happening behind the scenes. Their strange, illogical, and often surreal nature reflects the fact that they were never meant to make sense. They are the mind's attempt to impose order on noise. Not all researchers agree with this interpretation. Another influential theory suggests that dreams serve a primary evolutionary purpose, preparing us for threats. This idea is based on the observation that the most common emotions experienced in dreams are negative. Anxiety, fear, anger, and abandonment appear far more frequently than joy or peace. According to this theory, dreams function as simulations. For early humans, the world was unpredictable and dangerous. By repeatedly experiencing threatening scenarios in dreams, individuals could become better prepared to handle fear and stress during waking life. Those who dreamt of danger learned to cope with anxiety. Those who coped better survived,
and passed on their genes. From this perspective, even nightmares have value. They are training exercises, not malfunctions. Despite decades of research, no single theory fully explains why we dream. The ideas discussed here are influential, but they do not enjoy universal agreement. They represent only a small portion of the scientific conversation surrounding dreams. And that uncertainty is part of what makes dreams so compelling. We can measure distant galaxies with astonishing precision. We know their size, their composition, and their future. And yet, the dreams you had last night, experienced just inches behind your eyes, remain deeply mysterious. Every night, the brain creates entire worlds, and every morning, most of them disappear without a trace. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more explorations of the mind.